Welcome to the apocalypse. What you're seeing here are the signs of the entire atmosphere collapsing in on itself. The blue represents moisture as it's blown around by the winds in the northern hemisphere of the Earth. Darker blue means more moisture, and white shows dry areas. No need to worry, this is only a simulation of the Earth, and, in fact, this simulation is total garbage. Unearthly rainstorms develop around the equator. They are so intense that they explode like bombs, sending rippling waves of energy screaming across the surface of the Earth. The simulation's predictions aren't realistic. When was the last time that it rained so hard that the sky exploded, figuratively speaking? Not only that, but the Earth that you're seeing is a simplification. It has no oceans, no ice caps. The model doesn't even include the sun. Weather predictions and climate simulations, on the other hand, use massively complex models of the Earth in order to mimic the complexities of real weather, like what is being shown in the satellite pictures you're seeing above your head. So, why would we care about a flawed prediction from a tremendously simple model of Earth? What if I told you that generating simulations like this one is an integral part of predicting the weather more accurately, or even improving our ability to study climate change? Sounds kind of wild, right? Let me explain why it's not. Imagine setting up a full simulation of Earth like cooking a stew. You start with a good stock base, a model that predicts the wind, temperature, and pressure in the atmosphere. Then you throw in a cloud model, and an ice model, and a soil moisture model, and solar radiation, and atmospheric chemistry, oceanic models, oceanic chemistry. What about sources of dust? What about tree cover? It's a complicated and delicate balance. What if you created a complex simulation of Earth that included the bug that caused that apocalyptic simulation I showed you before? It would be like making a stew with dish soap in the broth. In the full stew, it might not be easy to figure out exactly what went wrong with the prep, you just know that it's bad. In a full Earth simulation, it would be similarly hard to identify what went wrong. Think about the simplified model of Earth as a way of tasting the broth on its own before adding it to the stew. The simplicity of the setup makes it easy to identify problems. The simplified version of Earth can even be used to compare the tools that governments around the world use to predict the weather, as well as the tools that climate scientists use to study the changing global climate. In this case, rather than tasting a broth to make sure that it doesn't have dish soap in it, we're tasting hundreds of broths to figure out which ones would be good in certain stews. Above your head, you see predictions of the same model Earth from before, created using different mathematical tools. So each of these predictions is pretty similar, but not identical, and after the software glitch that caused the apocalyptic simulation was fixed, it also looks pretty similar to the others. The scientists who develop tools to predict the way that our atmosphere moves are actively looking to test the mathematical tools that they create. Making monstrosities like the simulation that we started with is part of the process of testing and improving the tools that are used to predict the weather. Hopefully some of you made it to the end of this. Thanks for going on this adventure with me. My name is Owen Hughes, and I'm an undergraduate researcher who is researching atmospheric modeling at the University of Michigan under the guidance of Christiane Jablonowski. If you want to know more about atmospheric modeling, you can read more at the lab website using the QR code shown on screen. This project was created as part of a science communication class put together by University of Michigan Museum of Natural History staff. I want to end by thanking them for the time that they put into the course and for forcing me to finish this thing. There will be links in the description to the sites that are up on the screen, as well as citations for the external media that I used, as well as some annotations about the data that I showed here. So take a look if you're interested.